Now, you have what's called the remainder theorem. Okay, let's talk about this remainder theorem. Let me write it. The remainder theorem says, if a polynomial f of x is divided by something of the form x minus k, okay, the remainder, what's the remainder going to be? The remainder, we'll call the remainder r. R ends up being f of k. R ends up being f of k. In fact, let's look at this one just up here. You know how we took this? We took this x cubed minus 3x squared plus x minus 8, right? And we divided it by x minus 1. Okay, so this remainder theorem is saying, hey, if I divide by something of this form, x minus k, so our k, see how our k is 1 in this case? Our k is 1, okay? If I can identify k being 1, now notice I am having to divide by something that's x to the 1 power, right? X to the 1 minus 1. So you can't be dividing by quadratics. It doesn't work for this remainder theorem, okay? Again, if you're dividing by something of the form x minus k, you identify your k, then you say, guess what? My remainder will be f of, in this case, my k is 1, right? Let's figure out our remainder. So what was our f of x? What was our original, our dividend, blanking it here? Well, remember, f of x was x cubed minus 3x squared plus x minus 8. So I'm really just plugging it into that, right? So I go 1 cubed minus 3, 1 squared plus 1 minus 8. And guess what that gives us? Negative 9. What was our remainder up here? You know, let's look at this. Hey, what was our remainder? Hey, there it is, right? There's our remainder, negative 9. That's what we got. So anytime you divide by something of the form x minus k, if you can identify k, right, you'll know your remainder. You can figure out your remainder, okay? Let's do another one here. Let's go ahead and divide. How about x cubed plus x squared minus 5x plus 3. We're going to go ahead and divide that by x plus 2, right? And you know what? Before we even start, let's talk about what's our remainder going to be, okay? What's k? Well, another way to write x plus 2 is x minus a negative 2. So our k, in this case, see how our k is negative 2, actually? K is negative 2. So if we plug in negative 2 into our dividend, okay, we end up getting 9. Our remainder should be 9, excuse me, at the end of this. Let's go ahead and do this polynomial long division, and let's see what we get. Okay, so I say what times x gives us x cubed, right? Well, that what has got to be x squared. Let's go with x squared. So x squared times x, x cubed. X squared times 2, 2x squared. Don't forget, change. All right, that's a minus now. X squared minus 2x squared, negative 1x squared, minus 5x. Now I say what times x gives us negative x squared? Well, that would have to be negative x. Negative x, throw it in, negative x. Okay, negative x times x, negative x squared. Negative x times that 2, negative 2x. Don't forget change, gone. Negative 5x plus 2x, negative 3x. Bring down that plus 3. What times x gives us negative 3x? That would be a negative 3. Negative 3 times x, negative 3x. Negative 3 times 2, negative 6. Don't forget. Change. 9. Hey, you see that remainder 9 there? We already knew that, didn't we? Well, let's write our answer here. So our answer is quotient x squared minus x minus 3 plus our remainder 9 over our, that's a 9 right there, over our divisor x plus 2. Okay, there it is. That's our answer. So hopefully you kind of getting the hang of this polynomial long division. Let's talk about the factor theorem now. The factor theorem. Okay, the factor theorem says a polynomial f of x has a factor x minus k if and only if, that's what that means, IFF, if and only if, f of k equals 0. Now think about this, think about what that means for a minute. If f of k equals 0, remember r equals f of k, so we're claiming that our remainder is 0, right? So if we have no remainder, when we do this division, f of x divided by d of x, right? And we get this remainder. If the remainder is 0, right? So we're not throwing anything onto the end. It's just a clean q of x, right? It's just a very clean q of x because there's no remainder here, okay? So a polynomial f of x has a factor x minus k if and only if f of k equals 0. And I think you're going to kind of see that as we walk through a couple examples here, okay? Okay, so let's factor. How would you factor then? Let's take this f of x equals x cubed minus. All right. So here's what this is asking us. Factor. f of x equals x cubed minus 19x minus 30, given that f of 5 equals 0. Okay? So first of all, this is saying our remainder, r equals f of 5 equals 0. So at this value of 5, 1, 2, 3, 4, 5, I have a 0 for this original function. That original function, x cubed minus 19x minus 30, okay? So if I'm going to go about factoring this thing, I know this factors cleanly. It factors very cleanly. It's another way I could say that. Maybe if you're thinking about with numbers, right? If you have 32, if you know one of the factors is 4, right? How would you figure this out, right? If you didn't know 4 times 8 was 32, right? You could say, oh, well, 32 divided by 4 gives me 8, doesn't it? Right? In other words, f of x divided by d of x should give me q of x. So this is my q of x. So I'm trying to figure that out. So all I have to do here, let me get rid of those there for a minute, is I got to take this x cubed minus 19x minus 30, and I got to just divide it by x minus 5. And I get this answer, and I put that answer there, okay? So that's how we're going to approach this problem. Now, if you don't mind, I'm going to show you a synthetic approach to division before I finish this, okay? So synthetic, and it's a quicker way to divide something of the form x minus k. Okay. So anytime you are doing a division, if you're dividing something by synthetic division, okay? If I'm going to divide, so I have this f of x, and I'm going to divide by something of the form x minus k, I can use synthetic division, okay? And here's the process. You're going to put your k there, and this right here is going to be your remainder, right there at the bottom right, okay? So for this problem, in fact, let me clear this page out a little bit, and then we'll actually come back to this. So let's see, what was that? X cubed minus 19x minus 30. We're going to divide by this x minus 5, right? Okay. So anytime I'm going to use synthetic division to solve this, okay? So if I'm dividing by something of the form x minus k, I can do this. What's my k? Well, my k here is 5, right? My k here is 5. So I say, here's the little step process to do this, okay? So I put my 5 there. Now I put all my coefficients from here. So I go 1. Notice there's nothing x squared. 1. I put a 0 for my x squared. Then I put the minus, oops, that's supposed to be a minus 19x right there. Sorry about that. Put the minus 19 for the x. Okay, minus 19x. And then you put the constant right there at the end. Okay? So you put those just in that order. And right here, this is, I like to, you see how I put a little bar to kind of, that's going to be where my remainder is. That's where the remainder is going to end up, right there. Okay? Now the process for this is you go straight down. That's a 1, right? 1 times 5, 5. 0 plus 5, 5. Now I go 5 times that k up there again, 25. Negative 19 plus 25, 6. 6 times that k over there again, 6 times 5, you see the upper left, 30. Negative 30 plus 30, 0. Our remainder is 0. Now look at it. If we'd have done it this way, x cubed, 0x squared minus 19x minus 30. We divide by x minus 5. We go, well, that's got to be an x squared. Let's see, x squared times negative 5. Negative 5x squared. X squared times, oops, change. 5x squared minus 19x plus 5x. Change, 6x minus 30 plus 6. 6x minus 30, change, gone. So you're like, okay, wait a minute. How is this the exact same thing as that answer, right? Because that's what I'm showing you, is I'm showing you another way, synthetic division, a quicker way, supposedly, to do that same process. You say, well, these are my coefficients of my quotient up there. So I have 1x, and that's 1 degree less than this. You see how we have x cubed up here? So it's 1 degree less than that. 1x squared. See the 5 plus 5x. This is going to go down in degree, plus 6. So x squared plus 5x plus 6. You see how it's the exact same? See how it's the exact same there? Okay. Let me come back to this. I got to stop this video right here. But let me do one more synthetic division, and then we'll come back to the 0 problem and finish that concept off there. Thank you.